Welcome to LDI 2.1. So this is our start of Chapter 2. At this point, you should be getting going on the reading in Chapter 2 and moving right along. But before I talk any more about Chapter 2, let's try a little example here, okay? So what are the big topics of this chapter is going to be why we're going to sample. So what I want you to do for me is read the sentence down below here, this one right here, okay? And count the number of F's in it. I'm going to give you about 10 seconds to do it. So go ahead and do that. Okay, great. So let's see how many did you got. How many of you got 3? Did you get 3 of them? Did you get 4? Did you get 5? Did you get up to 6? How many of you got 6? Okay, let's go through and let's actually see how many are there. So there's 1. There's 2. There's 3. There's 4. There's 5. There's 6. So the correct response for the number of F's that were in that sentence is there was 6 of them, okay? If you didn't get it right, don't feel bad. I usually get about 50% of the class gets it right when we do it in the face-to-face section. And the reason is that most of us don't really even see the word of. We just kind of skim right over it. So you were asked to take a census of the letter F's that fall in that sentence, and notice that you had, some of you, maybe not all of you, had a difficult time finding all of them. So as it turns out in the real world, that's more of the rule than the exception, is that it's very difficult to find all of the items in a population. And so it turns out that we really want to get good at sampling, okay? And sampling is a huge topic unto itself. It's actually a separate course. So we're just going to get the flavor of it, and we're going to move on out of this chapter, okay? All right, so let's take a look at a couple of definitions that go along with sampling. If you were able to take a census and you got every value in the population and you calculated a numeric summary from all those values in the population, then you would have calculated the population parameter. So notice that that's kind of nice there because it's the population parameter, okay? So the P goes with the P, all right? So back in the situation here, if you were to count all of the letters that are present here, I believe there are 86 letters in here in total, if I recall correctly. And if you take a look at the number of F's that we have in our sample, right, we have 6 of them. So it's the parameter here is 6 out of, it's not 86, 85, actually, I just did a quick count there. So the parameter here is that 6 out of 85 of the values here, the percentage of F's, is 6/85ths, or approximately about 7%, okay? If you were to turn that into a decimal value, all right? So the numerical value, the parameter for all of the letters F in there that show up in that particular one, the parameter was, let's just roll with 7%. So that was the numerical summary that we did on all of those numbers. Now a statistic would be a numerical sample, or a numerical summary that is calculated on all the units in a sample. And it's going to change from sample to sample. Let's come back to that in just a second. But a statistic would be is if you took a simple random sample of the letters from that sentence and counted the number of F's that showed up out of your sample, that would be your estimate of the parameter of the number of F's that showed up when we did the actual census, okay? Again, the nice thing here is that notice a statistic goes with a sample. So if it was sample data, then we calculated a statistic. Now notice that the title of this course is Elementary Statistics, not Elementary Parameters, okay? One of the things that you're trying to do here in this course is find good methodologies for estimating parameters, okay? That's the whole job of statistic. Its purpose in life is to estimate a parameter. Now, when you take a sample, when you do a good sample, and you get a good estimate of that parameter, you didn't actually nail it. In other words, you didn't get the exact value, you got an estimate of it. Now, when you take a second sample, you probably will get a slightly different estimate than you did the first time. And so that's what we mean is by the fact that a parameter changes from sample to sample, while on the other hand, a parameter is a fixed value. So statistics change from sample to sample, parameters are a fixed value, okay? All right, let's go do LDI 2.1. According to the campus housing fact sheet at a Big Ten university, 60% of the students living in the campus housing are in-state residents. In a sample of 200 students living in campus housing, 56.5% were found to be in-state residents. So circle your answer in the following. In this particular situation, the value of 60%, is that a parameter or is it a statistic? Well, it's what we were given by the fact sheet. So the fact sheet is telling us that this is the population parameter here. So that value would be the parameter, all right? It's based upon what they say of all students that live in the Big Ten university. Now, on the other hand, we did a sample of 200 students. So notice here, a key word was sample, and we even were given the sample size. And based upon that sample, we calculated a value of 56.5%. Notice that that is a statistic. Okay, well, that's a simple little LDI. Hopefully that helped you out, get you started in Chapter 2 and the whole stuff on sampling. And we'll see you all back here for LDI 2.2.